In this video, we're going to look at some basic applications of the unit circle to see how this circle actually works with trigonometry. And we're going to, I think, hopefully see that this is actually a very useful tool and in many ways much more powerful than just looking at a right triangle. In the last video, we looked at the idea that if we take in an angle, let's say we draw a radius from our center to the circle right here, right? That line is going to cross the circle here. It's also going to form an angle with the x-axis, and we called it theta. Well, I can complete this right here by just dropping a line down from that point to the x-axis, and we have a right triangle. And once we do that, we use the idea that this xy value represents the cosine, sine, and tangent of our theta, our angle right here. The idea being that the sine of theta is just equal to the opposite side from the angle, that's this, over the hypotenuse, and the hypotenuse is always 1 in a right triangle. So the opposite side here, this value is our height, and that's y over 1. So sine of theta is y. Cosine of theta is just x for a similar reason. Cosine equals the adjacent side, which is right here, over the hypotenuse, and this is just x, right? The other side is y, but this is x, so it's x over the hypotenuse, x over 1, or just x, and the tangent of theta equals the opposite over the adjacent, so it's the y over x. So what does that mean? Well, what if we wanted to find out the sine of something, or the cosine of something, or the tangent of something? That means all we have to do is look at our x and y values. Now, to understand some interesting implications of this, let's look at 4 really important, I guess, points. These 4 right here, because that's when we get some pretty interesting results. And let's just identify what these points are. First of all, this point right here, that's just 1, 0, right? It's 1 to the right, and it's on the y-axis. Over here, this is 1 to the left. Remember, the radius is 1, so it's -1, 0. Down here, we have 0, -1. So it doesn't go left or right, it's just a point that's straight down. That's 0, -1. And we have the opposite here, which is 0, 1. Okay. Well, we can actually find the sine, cosine, tangent of these 4 points. I think we'll see some interesting results. And already we talked about in the last video, well, the unit circle takes us beyond. It extends the idea of the right triangle because it allows us to find the sine, cosine, tangent of a right angle. So what if I had an angle? Let's look at that. If I have an angle that forms from the x-axis all the way up here, right, and that forms 90 degrees. Right here we have this line that goes right up. Now I could try and draw a triangle here, but it's not going to help me because I know I can't really even have a triangle at 90 degrees. So I need to use this idea of the unit circle. Let's look at what that means. Well, this point is 0, 1. So the sine of a 90-degree angle, it's a little bit too thick, that writing. The sine of a 90-degree angle is just going to be equal to the sine of 90. It's going to be equal to our y value, which is just 1. And the cosine of 90 degrees is going to be equal to our x value, which is going to be 0. And that's true, the cosine of 90 is 0, the sine of 90 is 1. The tangent of 90 is going to be equal to y over x, or 1 over 0. 1 divided by 0, we can't divide it by 0, so that's undefined. So that's interesting. Already we've established that some of these trig functions are undefined. If we look at let's say our angle opens up to 180 degrees. We draw a line that crosses to the circle. What's going to happen here? Well, now it's hitting this point. So the sine of this angle, the sine of 180 degrees, what does that equal? It equals the y value, which is now 0. And the cosine of theta is going to be equal to the x value, which is -1. And that's the cosine, of 180 degrees. The tangent of this theta, the tangent of 180 degrees, equals y over x, which is equal to 0 over -1. So that tangent is just equal to 0. And we keep going with this. At this point right here, the sine of this is 270 degrees, which we definitely couldn't fit into a triangle. We draw our line to the circle right there. Well, the sine value of 270 is just -1. That's the point that the line crosses the circle at. So the sine of 270 equals negative 1. The cosine of 270 is equal to the x value. So the cosine of 270 is equal to 0. And the tangent equals y over x, so it's negative 1 over 0. So again, the tangent of 270 equals 0. Right? Negative 1 over 0 is just 0. Excuse me, negative 1 over 0 is undefined. What am I saying? This is actually interesting. I was wondering what I was saying there for a moment. Let me just tell you what I mean. If we have negative 1 over 0 here, right, there's a nice symmetry here in the circle. This point and this point are both undefined for the tangent. The tangent of this point is equal to negative 1 over 0. The tangent of, right up here, the tangent of 270 equals negative 1 over 0, and we can't do that. We can't divide anything by 0, so that point, that angle is undefined for tangent. And let's look at full rotation, 360 degrees. So this is the tangent of 0 or the tangent of 360. Well, let's look at the sine and the cosine. The sine is going to be equal to the y value. So just as it was over here for 180, sine is going to be 0. So the sine of 0 degrees, or 360, equals 0. The cosine of 0, or 360, is equal to 1. Here, for 180, it was equal to negative 1, so there's an interesting symmetry there. And the tangent of 0 degrees, or 360, what does that equal? Well, it's going to be equal to 0 over 1, which is just 0, right? It's the y over x. And that's interesting too to me because we have these 2 points both equal 0 for tangent, whereas, look at this mess, these 2 points are equal to undefined. So there's going to be interesting symmetries all around the unit circles, and we'll explore some of those in future videos.